simplified that production system down to just nitrogen and potassium and phosphorus and the physical texture of the soil and the potato. And then, of course, you get these spiraling out of control cycles of pest impacts that come through there, and then you use more. So I bring that up to point out the subtle ways in which we might have come to prefer settings and ideas of beauty and ideas of simplicity that aren't really in line with how nature works. And so what are we going to do about that? And then the third one is climate change, right? So this is actually an important point here because the so-called insect apocalypse is not being driven by climate change alone. And that's very important. At best, it's a co-equal of these three effects. And the reason for that is that insects are extremely sensitive to small changes in their environment. They're extremely sensitive to temperature changes, changes in phenology. So what is phenology? Phenology refers to the sequencing of things in the natural world. So it refers to the order in which things happen in the year. This flowers at the same time as this insect is hatching. These fish are running in the river at the same time as these insects are in their second molt, which is when they're most able to be hunted by that fish. This comes before that. This happens at the same time as that. That's all phenology. And so, when people's natural history, careful, detailed natural history journals from 100 years ago are one of the really interesting documents for studying climate change, because they give us a picture of phenology and how that's changed since that time. But insects are really sensitive to changes in those sequencings. And they're also really sensitive to changes in their food sources. So so these are the three that there's really strong empirical evidence that these things are driving the insect population collapse. There's a fourth one that there's emerging evidence that it may be a fourth factor. It may not be as significant a factor as these three, but it's also one to think about. And what do you think that is? Totally unrelated to any of these things. Actually, there's one of them it's a little bit related to. But what's that?
Bugs hitting windshield?
No, very, very minor. Yeah.
Electromagnetic fields.
Maybe, although I haven't seen any research on that. But it's actually, you're getting closer.
Give us more clues.
Not the changing of polarity.
Yeah, probably not. This thing is actually sometimes used, and one of the ways researchers started to realize that this is a question that should be asked is because this thing is sometimes used as a non-chemical pesticide method. It's sometimes used to reduce pest populations on farms.
Fire.
Not fire.
There's electric
Lights.
Lights.
Nighttime lighting. Nighttime lighting. Because the nocturnal insects are totally unprepared for how to operate with nighttime lighting. The diurnal insects are woken up out of order by the nighttime lighting. There's all kinds of effects nighttime lighting has, and it basically interrupts the insect's ability to forage and reproduce in a number of different ways that are different for different kinds of insects. So there's less research on the nighttime lighting than the other ones. I'm not prepared to say it's equally important as these, but it is pretty fascinating that some industrial farms use nighttime lighting to kill pest insects. And so that might be an indicator that it's part of what's killing other kinds of insects. And obviously we have a world that's flooded with nighttime lighting. So anyway, these are some stressors, and some of these, obviously, there's a big worldwide push that hopefully could get even a little more of a push to reverse climate change right now. But on the scale of one farm, on the scale of one agricultural neighborhood, on the scale of one community, we can't really affect climate change on that scale. We can affect it on a global scale, an industry-wide scale, or maybe a regional scale, but not the scale that we usually have influence over. But we can affect habitat loss. We can affect agricultural poison use. We can affect nighttime lighting, and we can even reverse and restore habitats that had been undone. So I just wanted to give a really big picture view of what we're talking about with what the design responses might look like. There's some of them that are attempting to essentially kind of do harm reduction and stop the impact from agricultural toxins. Maybe there's harm reduction we can do with nighttime lighting, but to actually go beyond just harm reduction, what we're really talking about in the meantime while we work on climate change, what we're really talking about is habitat restoration. Right? So that's where a lot of the focus might end up being. Any questions about that on a really big picture scale, both like, we're going to talk a little more in a minute about what insects are being most affected and what the implications of that are, but big picture questions at this stage, yeah.
You said co-equal, any estimate, are they a third?
I think they're probably about it's good enough, I think it's probably good enough to consider them a third.
Yeah.
Yeah.
The flip side of this is that these things are causing in other insects just an explosion.
Totally.
Controls.
Yeah, totally. Yep, and then without the biocontrols of their predators and parasites that they might usually have to keep in check. Like, so, let's take the example of the spotted-winged Drosophila. How do you say that?
Drosophila.
No one knows. Drosophila. Yeah, so the spotted-winged Drosophila, okay? So, who has ever felt some, like, pearl clutching about the spotted-winged Drosophila? I know I have. Do people even know what this insect is?
Yes.
Okay, let's talk about the spotted-winged Drosophila.
How do you see the spots on their wings?
You got up real close.
Is it different from the spotted wing lanternfly?
Yes, it is different. Oh, we can talk about the lanternfly, too.
Okay.
Okay, so the spotted-winged Drosophila is a new agricultural insect pest that is entering southern New England currently. It is in, you said perfect? Yeah. It is in Connecticut currently. And
it's in Maine also.
It's in Maine, it's in Massachusetts, and it is a sawfly who lays her eggs in thin-skinned fruits, so mostly berries. Thicker-skinned tree fruits, the skin is too thick for her to penetrate it to lay her eggs, so she's going after raspberries, she's going after blackberries, she's going after elderberries, she's going after, things like that.
Is this a fruit fly? Or
Yeah, it's a fruit fly.
Yeah.
It's a very small fruit fly, but it's one that causes a bursting of the fruit, and so that you get economic losses. If you're doing berry production, small fruit production, you get economic losses from the fruit being burst, and then you can get an infestation of them where they're kind of reducing your ability to produce the fruit.
And they lay in unripe fruit, which is their difference from, rather than post-ripe. My raspberries get gooey.
Right. Well, they not too unripe, like just on the edge of ripe.
You pick them early and freeze them.
Yeah, right. So there's things people have figured out. One of the interesting observations that's been made about the Drosophila is that it's mainly a problem in monoculture or near monoculture fruit systems. So in some of the, and again, we need to learn more about this, but the early observations are that in the highly biodiverse forest garden multi-species systems, you get a little wave of Drosophila for a couple of years and then it sort of settles out. And the hypothesis is that that's because of all the predator and parasitoid insects that are around. And so that there's enough biodiversity of the ones who could become natural biocontrols available that happens, versus when you have a monoculture. And of course, the economies of scale of farming dictate things close-ish to monocultures a lot of the time. So there's not an easy solution to that. But the hypothesis would be that more biodiversity and more wild biodiversity in and near the small fruit production will help with the Drosophila. So that's a little bit. Now the spotted lanternfly is a whole other conversation, which I think we'll not get into right now. But people know about the spotted lanternfly, right?
No.
Okay, so the spotted lanternfly is a new leaf-shredding pest insect that is moving off the Atlantic coast now also. It is in southern New York State. It's in Connecticut in some places. Hasn't so much made it to Mass yet. But its main host plant is what?
Grapes?
Not grapes. Ailanthus, the introduced tree of heaven. Right. So now, a lot to say on that, but the main point I want to make, to your very good point, is that we ain't seen nothing yet around this. That the scale of biological migration that is coming dwarfs what we've experienced so far around so-called invasive species. So, you know, I had a conversation once with someone in eastern Massachusetts about, we were talking about the introduced plants, the introduced insects, and, you know, and this real desire to get rid of them. And I said to her, I said, you know, we're never getting rid of them. Like, they're here to stay. And she let out this big sigh. She was like, oh, do you really think so? I was like, yeah, I really think so. And we could have an interesting conversation from there. But a future of 100% removal of these introduced species is not going to happen. They're here. And some of them are in the process of naturalizing. There's many species that have naturalized to the point that they're essentially benign. They're, you know, like apples and, you know, a bunch of other things. There's some of them that might continue to have invasive type effects. There's new interactions we won't see. There's whole emergent new ecosystems happening in cities especially, with plants and insects and animals interacting from all over the world that never interacted before. So it's an exciting time to be alive on planet Earth. And it's just not going to look like what we're used to when we grew up. And so that's another place where the attachment to a certain image, which itself was an altered, impacted remnant of something else, you know, can be held up to a little bit of self-reflection and a little bit of examination when everything's changing. So, related to all that, this is just sort of what's happening globally. Whole system collapse and increasing difficulties on all fronts. But let's talk a little more about the insects who are most at risk here, because it's not all insects, but some of the insects are really important. So, these are the 4 orders of insects who seem to be particularly at risk from rapid population decline and who are in particularly important roles in ecosystems. Lepidoptera, Hymenoptera, Coleoptera, and Orthoptera. So who the heck are these?
Butterflies.
Yeah, so who are Lepidoptera? Yeah, Lepidoptera, we got the butterflies and moths. Right? Very, very impacted by these factors. Who are Hymenoptera?
Bees.
Bees and wasps. Rather important for the continued production of food all over the world, as well as their own intrinsic right to exist. Who is Coleoptera? Beetles. Yes, hugely important. And then who's Orthoptera?
Grasshopper.
Yes, grasshoppers. So these are kind of, if you were focusing on anything, I'd say you're focusing on these 4 taxa. There's lots of other ones to think about, but this covers a lot of it, at least in New England. And there are concrete things we can do about habitat restoration for these taxa. And actually, I just this week got to see and take photos. I didn't get them into the presentation yet, but I'll tell you about it, about a beetle habitat strategy that I'm so stoked about. So we'll get to that. Okay, so some ecological design responses. Well, if we're going to use some design thinking to think about what to do about this situation, we have to start with what is the specific situation that we're working on, not a general situation. So it's always more valuable to work on concrete specifics. And so that begs the question of the whole under management. So this is a holistic management question. And so what I'd like you all to do is find a buddy near you in the room and work with your buddy to identify your whole under management. So what are the entities, the resources, and the systems that are under your direct influence? The entities, the resources, and the systems that are under your direct influence or management. And maybe that includes land or a farm business. Maybe that includes, we'll get there in a second. One more instruction. Maybe that includes financial resources. Maybe that includes, an organization that you're the director of. Now, if you can, it would be great for you also to identify at least 1 or 2 entities or resources or systems that are beyond your current whole under management. But if you do a little bit of organizing, then and collaboration, then you could influence them with other people. So who and what are within your current hole under management, and what's just outside of it that you could reach for it if you do it with others. So spend a few minutes with your buddy seeing if you can actually take some notes about each of these categories for yourself in your current life situation. Another moment to wrap up your thoughts. And come on back. Come on back. So, did anything surprise you when you worked to answer these questions? Did anything pop out at you as, interesting?
Actually doing some of the things on a very, very small scale.
What popped out at me? I'm sorry.
Go ahead.
What was the example?
What popped out at me was that management is a very difficult word for me to get my arms around, because influence is much different from management, and influence is much more the emphasis.
Great. Yeah, and you know, and management has the idea of management has a history, and that history is rooted in a machine paradigm of thinking about living things. So I'm using it because of its association with holistic management, which is a very powerful set of questions that are asked. But it's a problematic word also, so we got to look at that. Yeah. You had something up here?
I was surprised that there's so much we could do.
Okay, right.
When we started talking about it, I was like, oh yeah.
Yeah.
So tell us.
Oh yeah. Well, we were just talking about. I work for a nursery who use conventional means, so I could be
Right, and that would probably include, a range of analyses about
Right.
what the transition to non-toxic methods would actually involve.
Right.
It might involve flame weeding. It might involve increased labor costs, decreased chemical input costs. There might be a financial implication of it that you could actually think through and be prepared to say something about.
Well, and that's true. You have to come prepared to the table with a plan for that. Let's say yay or nay. But also landscape design.
Yes.
I was just thinking that you always go forward and give the customer what they want and make sure that you're meeting their needs, but you always have to say, and then this is going to be the area that you don't mow.
Right.
This is going to be the area
Totally.
where you just leave.
Totally.
I don't know how it's going to go over that.
Cool. Good ideas. Yeah, over here.
We had a tough time defining entities versus resources versus systems. So for entities, we thought of land
Right.
and different ownership or rental of land. Bringing up, is nursery considered an entity? How
Yeah,
do you identify?
I think right now the distinctions aren't too important, but I would actually suggest that businesses and organizations are entities.
Not individuals?
And individual humans are entities, but we usually don't have full management over them. If we do, maybe something's gone a little off track. And land is an interesting question, and I actually want to hold that thought and talk about it in a second from a different vantage point, because what is land is an important question in this conversation. Yeah.
It's both a resource and a system.
It is definitely a system, and there are resources there. From a resource, from a pair of glasses that sees resources, there are resources there. So the next part here that's very connected to these questions we're asking is about place, because where we are makes a big difference in this conversation. And so I want to zoom out for a few minutes with a perspective on place, and then ask you to do a little more thinking with your buddy about what place might have to tell you about what your opportunities for influence might be, and how they might work. So let's just take a little look at this. So, what the heck is this?
It's more like Western.
Oh yeah, what's that on the upper? What's that on the upper left? Ah, the edge of the quabbin, and what's that on the upper right? Boston, yeah. So it's very valuable to look at land sometimes without any political boundaries, right? This is just a satellite image, and it's not a satellite image we're used to focusing on because there are 3 different states in this image, right? So what's this down here? Providence, yeah. Yeah. So there's Worcester, right at that city, right in the middle. Yeah. So this is a particular territory here. And so here's another way to look at this territory. Well, first of all, what do you want to learn more about when you see this image? What is your eye and mind drawn to that becomes a blank spot and you realize there's something you don't know?
The green spaces.
Yeah, what's going on in these green spaces? Like, what's going on in this corridor of green space?
Yeah.
Look at that! There's almost no urban or suburban development in this whole corridor. Yeah.
46, I think.
Goes between Providence and Worcester.
So let's take a look at this image now. Another way of looking at the same place. What is this? Watershed of who?
Blackstone River.
The Blackstone River. Yeah. So what? Tell me about someone who knows a little bit about the Blackstone River. If there's like a Blackstone River expert here, we want to hold off on you for a second. But someone who's heard something about the Blackstone.
Well, I know that down around Uxbridge, there's there was a mill on the Blackstone River.
Yes.
So
Yes.
a
A lot of industry. Yeah. And up here.
I think it used to run through Worcester, but now it's paved over.
Right, so yeah, it actually does include a lot of Worcester, but in fact there's a bunch of tributaries that converge a little south of town into town.
John Todd.
John Todd did a bioremediation cleanup of part of the Blackstone.
Yes, attempted, yeah, for sure. Well, I mean, it'll take a lot to do because in 1990, the Blackstone River was declared the most polluted river in the United States in terms of particulate pollution. Because of hundreds of years of industry and also some other things that we'll zoom in on in a second. And a bunch of this, now here's a clue to what's going on with this green corridor here. Look at what's going on here. What is this line? Yeah, it's a ridge. It's a watershed divide, right? So these are probably hills that haven't been developed, and maybe they're steep enough that that's part of why. Maybe they're under conservation. Who knows? But yeah, very very interesting. But it's also not a very large watershed, right? Because what's going on right down here? Where does it end?
The ocean.
It ends in Narragansett Bay in Providence. Right? So it's a very particular stretch. Now, if we zoom into here's another perspective on this. Yeah, Worcester, right? Yeah, so where are we right now?
Well, there's Worcester Airport.
Yeah, there's the airport, yeah.
To the right of the airport.
Or to the right of the airport, yeah.
Yeah.
Oh, that
Yeah, so
cluster.
we're right around there.
Yeah, that's where we are.
Yep. Okay, so there's a detail on this image that's a very important detail in the story of this river system. And I'll point it out to you unless someone knows what we're looking for.
Give us more clues.
It's not a dam. Most of the dams are way further. Actually, the Blackstone River has a natural falls very shortly above the ocean. So the stretch of where the river is tidal is only about half a mile. And then it hits a falls, which were turned into a watermill very early on. But historically, this is a salmon river. Historically, this is a salmon and eel and lamprey and all the migratory fish river because they could get up those falls before the dam went in. So all the North Atlantic migratory fish were part of this larger system historically. And when they die in their migration, the insect populations and arthropod populations that are the decomposer community on those fish carcasses take all of that protein from the ocean and they take all those micronutrients from seawater in the bodies of the fish, and it goes all the way out into the whole terrestrial ecosystem. So it's like the fish are like a giant conveyor belt of nutrients from the ocean inland. Because in this part of the world, the rainfall exceeds evaporation. And that means there's constant leaching of nutrients down into lower soil horizons, down into drainages and basins and larger basins, and back into the ocean. The fish are how they come back. The fish are how the ocean nutrients are returned to the land. Or used to be. And so that's what the dams interrupted, was that relation, that really, really ancient relationship between the uplands and the ocean. Now, there's other ways that those nutrient cyclings happen too, but the migratory fish are one of the biggest ones, maybe the biggest one.
Once upon a time, would they have gotten all the way up to Worcester?
Yes.
Okay.
And there's historical documentation of that,
Yeah.
of people fishing salmon in Worcester. Yeah.
Lincoln Square.
So I just was talking to a fisherman who fishes in the Quabbin,
Yeah,
and they fish salmon,
they do.
Atlantic salmon,
They do.
in the Quabbin.
Let's talk about that.
And I said, well, how is that possible? Because they didn't come all the way up from wherever. And he said, no, they think that the Quabbin is their ocean.
Right. So in that case, they were stocked. They were introduced there. They were introduced there after the Quabbin was dammed. But in other cases, it goes back a lot further than that. So there's also those same freshwater Atlantic salmon in Lake Champlain, in Vermont, New York, and in a lot of the bigger lakes in Maine, inland. And they're there since the Ice Age, because when the ice sheets were receding, Lake Champlain was directly connected to the Atlantic Ocean for about 1,500 years, because there was the relationship between the rebounding of the continental crust from the weight of the glaciers. I just want you to picture that for a second. This is true here too. That when you have a mile-thick ice sheet over your head for 40,000 years, that weight compresses the crust down into the Earth's molten mantle by hundreds of feet. And then when the glaciers melted, the land level is hundreds of feet lower than it is now, but the ocean level was also hundreds of feet lower, and in fact even lower comparatively because all the water was locked up in the ice sheets. So the ocean level is rising faster in some cases than the land level is rebounding. Sometimes the land level catches up. So that's where you get some of the coastal clay deposits up in northern Maine especially come from that period when the ocean level re-rose faster than the land had rebounded yet. And you got clay deposits, and then the land rebounded and exceeded the water level. And there's parts of northern Quebec that are still rebounding today because they had continental glaciers only 5,000 years ago. So the point of all that is to say that during that period of time when the rebounding hadn't fully happened yet, Lake Champlain was part of the ocean, was part of St. Lawrence Sound, so part of the St. Lawrence Seaway. And you had the full range of marine animals there. And then when the rebounding happened, it slowly returned to fresh water over a period of 100 years or so. And some of them adapted to that and lived with fresh water for 12,000 plus years, including harbor seals, which were hunted to extinction. There were freshwater harbor seals in Lake Champlain that were hunted to extinction in the 1800s, and salmon, and sturgeon, and sea lampreys, and all the ones who used to migrate up these rivers still live in some of those big lakes. So that's a much bigger view of this larger area of land we're in. But, I mean, these are some of the just wild stories that we're walking around on top of. And, again, if we just look at the snapshot of our own lifetimes, we don't see it. So people used to be fishing salmon in Worcester, and they were fishing eels and lampreys in Worcester. And maybe some of those, because the eels and lampreys are the ones who can climb up the walls of the dams. The lampreys use their sucker plate to climb up the dam wall. And the eels can get up because they're tiny when they come back. Because what's different about an eel than a salmon?
Everything can go on land.
Well, sometimes, but...
Oh, the order of when they reproduce.
Yeah, right, because they live as adults in freshwater and breed in the ocean. And salmon and everybody else we're talking about breeds in freshwater and lives as adults in the ocean. So the eels, when they come back, they're about an inch long. And they climb the wall of the dam. Yeah. So that's pretty amazing. But there's a detail in this map that is a huge part of the story of this river basin. It's right there. So what is that? Anyone have a guess? It's the Worcester wastewater treatment plant. and it empties into the Blackstone River. And now, of course, ordinarily it's supposed to purify the water before it goes back in, but what happens during a storm surge? You get what's called a combined sewer or combined sewage overflow because of how the overflow systems were set up back 100 years ago. And so you get a resurging of raw sewage water into the river. And so that's the source of a lot of the nitrogen and phosphate explosions in the river, which you get algae blooms from, and then when they decompose, it pulls all the oxygen out of the water. So what does any of this have to do with insects?
Oh, nothing for them to eat.
Nothing for them to eat, because how many of these insects have aquatic phases of their life cycles? Right? And so when you partially kill a river system, you're also affecting all of the migratory terrestrial to aquatic insects that are part of that river system. You're not just affecting the fish in the stream of the river. So all that is to say that there's some of these, a lot of these strategies we're going to talk about are ones that are happening on land, and they're ones that you can kind of organize with your neighbors around or do yourself. But I also want you to be thinking about, and even if it might take our whole lifetimes to figure out, I want you to be thinking about how can we actually repair and restore these larger land and water bodies beyond just the lines of my private property? Because these private property lines, if you think about where these came from, they are the way that the land surveying was done by the invasion of European people hundreds of years ago was such that it had almost nothing to do with the underlying natural characteristics of the land. It was essentially arbitrary. It was literally a grid that was drawn. And you can still see that in the layout of town shapes in Maine and Vermont, for instance, where they're all squares, because that's a consequence of the grid they were using to survey the whole land. So the private property we have now is a many times fragmented remnant of something that never had to do with the underlying land in the first place. And so the larger physical processes of watersheds, the larger physical processes of the reproductive cycles of animals have nothing to do with our property lines. They're totally unrelated. And they move across them like they're not even there. So that's one of the big reasons why this project of making the web of life work again somehow cannot just be done by individuals acting with their private property. It's going to require forms of cooperation and collaboration that American individualism is really spooked by. So I just want you to sit with that a little bit, and maybe even that inching out into organizing and cooperation might push into uncomfortable territory around what we think about as ours. Right? How much of what's ours is actually theirs in terms of the fish and the insects and the plant communities and the people whose land was stolen, right? So I want to give you a peek at a framework for how to think about different types of design interventions, different types of interventions in a system, different types of actions. And so this is developed by my teacher Carol Sanford and the work that she does, and it's called levels of work. So the lowest level of work here is the level of stabilize. And what you can imagine is that you have a patient on the operating table who has been through a near-fatal car crash, or you're responding to an emergency situation. And the first thing you're doing if you take an emergency medicine is you stabilize the patient in the situation, right? So what is that first? What's that three-letter acronym in emergency medicine that you're looking at first? ABC, airway, breathing, circulation. That's because those are the things that can kill someone in a moment. So you have to stabilize the basic functions of life to even be able to repair the damage, right? So sometimes on our farms, on our landscape, in our businesses and organizations, we're actually at a level of stabilization work where the thing we're trying to do is going to die unless we take immediate action. And that's kind of an extreme situation, but sometimes we have to do stabilizing work, and there are times when that might be true, like all the effort around preventing species extinction is often at the level of stabilize. So, for instance, the California condor population, when they went out in the 80s, and they actually captured every last remaining wild California condor. They found them all, and they took them all into captivity, and they spent 20 years redeveloping the population with enough genetic diversity that they could reintroduce some of them. So that was 20 years of stabilize, essentially. And now there's California condors all over Big Sur and in a few other places. So that was a success at the level of stabilizing that population. And God knows we're going to have to do a lot of that in Australia right now. So the next level of work is called operate. And operate is where you've got the patient on the operating table, you've stabilized the vital signs, and now you're operating to repair the damage. So this is about kind of repairing harm that's been done or redesigning how something's working at a fundamental level. So sometimes, we might have, maybe from a business or organizational point of view, you get the short-term cash flow loan, and then you go and work on the kind of earnings and margins issues that made you have to take out the loan in the first place. You're still not working on improving the business. You're just working on making it function again. ways. Sometimes, especially with watersheds, we have to do that. We have to operate on the basic biophysical processes, and sometimes that looks like dam removal. Sometimes that might look like removing the source of the pollution, so that something can resettle, and we don't even know what form it'll take after the pollution's removed. So the next level of work is maintain. So that's when you've operated on the patient, and now you're just maintaining the success of the operation and maintaining health and the basic ability to function. So sometimes, a lot of the time, we spend a lot of our time in maintaining. We spend a lot of our time in just maintaining a situation. But what I hope this makes clear is that if we've gotten down to the point where operate and stabilize are needed, then it's not sufficient to do the work of maintaining. We actually have to do the more challenging work of operating on the patient, not just taking our vitamins. Right? And so there's some assessment to do of what level of work is required by a given design situation. And it might not always be sustainability. So then there's actually improve. And the improved level of work is, it's like once you've maintained a certain level of health, then you can actually start rebuilding the muscle mass that you lost during the surgery. Right? So this might be where we're actually working to restore ecosystem functioning again and reestablish habitat that's actually usable by those populations. Things like that. Or it might be where we're, inquiring into not just the current functioning and maintenance of a business or an organization, but we're inquiring into where to take that business's offerings or that organization's mission from here and developing new things. And then the proposal is that there's a fifth level of work called regenerate. And this regenerate is not just about more improvement. And that's a weakness in how a lot of people are talking about regenerative agriculture, because they're talking about it as just going beyond doing more of what's good in organic and sustainable agriculture. And so I think what the idea of regeneration is challenging us with is about going back to what's unique and essential about a situation, going back to what's unique and essential about an organism or a place or an endeavor, and breathing life into it and reimagining it from that starting point. Right? And so often we don't always get to a regenerate level of work, especially if there's work to do at some of the lower levels. But I just wanted to offer you this, and we're going to come back to it when we do our design exercise at the end here. Okay, insects. With all that in mind, there's a couple principles of what these insect populations need, and it's so granular, species to species, that if we focus too much on the individual species, we lose the big picture. And often we don't even have enough scientific information to be able to confidently proceed on the level of an individual species. Some species are essentially undistinguishable from each other even though they have different reproductive needs. So broad principles of how this works. One of them is full season nectaries. So nectaries that are flowering the entire growing season. This is an issue with single species cover cropping. So if you have a mustard cover crop, for instance, you get this huge flush of mustard nectar all at once, and then it's gone. And so for that reason, single species cover crop is not considered adequate insect habitat by the people who've studied what is kind of the bare minimum. It's sort of a bait and switch. Instead, the diversity of nectaries that bloom from the beginning, the early honeybees, or the early bumblebees and everybody else, there's research out of Cornell about the intense value of red maple trees for the early season nectaries, the volume of nectar produced by red maple flowers before there's almost anything else in the landscape. Red maple, who's been considered a junk tree by a lot of modern forestry, but they're doing a big, big thing for insects. So in addition to full season nectaries, whole color spectra. Because different insects have different eye biology that's adapted to find different colors and see different colors. And so some insects see, and in general insects see way more of the color spectrum than we do. So some insects see not just violets and reds, but they actually see into the infrared spectrum. So things that might look like red to us actually have striping and patterning on them in infrared light that insects can see and we can't. And then same in the ultraviolet spectrum. A lot of the white flowers have incredible, brilliant designs and patternings that are invisible to our eyes, but they're like landing strips for insects. Right? So that's kind of a wild thing to contemplate, that they're actually seeing more of the universe than we are. But at least getting the full color spectrum we can see involved is going to do better at serving a whole range of insect taxa than just one color that we happen to like. Okay, diverse native plant species. That seems obvious, but it's both really interesting and really tricky. So a lot of native plant species are hard to find. They're hard to source. They're hard to propagate. There are major supply limitations in the native plant material that is available in New England. For instance, there's not enough nursery production and seed collecting that's being done of that material for even the current restoration projects that are underway, let alone the scale of what might be needed. So that's a business model opportunity for someone, and it points to the fact that it's not, like, you wouldn't want to necessarily order native plants from Oregon to plant in Massachusetts, because their genetic history and adaptive history, even just within a few generations, is oriented towards a set of conditions that are totally different than what they're going to find here. So the more similar the climate conditions the plant is grown and nurseryed out and developed in, the likelier it's going to be site adapted to where you're planting. So that's an interesting thing to think about. And you can also get into things like collecting your own native seed and things like propagating some of your own native plants if you learn enough to do it well. And then there's also the interesting thing of who is actually going to grow where, and who's going to grow well with who. And a lot of that is based on observation of ecosystems, and some of it is based on trial and error, and some of it is based on making mistakes and making guesses and proceeding with them. And it's related to the fact that a lot of this wild biodiversity we just still know very little about, right? Like, think about the trillium. This flower people plant in their gardens, all over the forest in some places. But do you know how trilliums reproduce?
It's a little bug.
It is a bug. What kind of bug? It's an ant. And how do the ants drive that reproduction? What do they actually do?
They eat the rhizome on the seed.
Yeah, the seed has this little packet of fats on it. So it has this lipid packet that is there to feed an ant. It's like the payment to the ant who is carrying them into the ant hole, into the ant mound. And then they germinate in the environment of the ant mound, and there's all this mulch and compost in it from all the shredded leaf matter the ants are eating. It's like a prepared planting spot, and they grow there. But the only way their seeds move around other than gravity is by ants, right? So every native wildflower has some just mind-blowing story like that, where there's this particular symbiosis that we mostly know nothing about and never see, and has to happen in order for the thing to work. So there's a lot of learning to do about this biology, and a lot of learning to do about how they've come to depend on each other over time. So another example, this is with marine life, but river mussels. So river mussels are a big fascination of mine and a lot of people's, and they're mostly gone from a lot of the rivers they were in historically because of nutrient pollution and sedimentation and a lot of other things. How do river mussels reproduce? It's utterly wild. It's like sci-fi wild. So river mussels only can reproduce through minnows. So what they do is they do the thing where they spray their sperm out into the water, and then the other one sprays eggs out into the water, and it combines, and then they grow a little larval mussel. And that mussel, that larval stage of the mussel, is a parasite who parasitizes inside the mouth of a minnow. And there's only a specific set of minnow species that each species of mussel can parasitize at that stage. And those minnows then carry them wherever they're going, and then they grow to a certain size and detach from the minnow, and then they grow into a mussel. But that's the only... Have you ever thought about how mussels get upstream? Right? They only can walk a short distance. They're not very mobile. They're relentlessly carried downstream by the movement of water. It's in their reproductive cycle that they move back upstream via minnows. So if you're trying to restore river mussels to a river, you have to have the right minnow in the river also, and people mostly know nothing about which specific associations exist right now. So just to give you a picture of the beauty and complexity of these co-evolutionary relationships, and the fact that we mostly don't know what we're doing, and there's a chance to learn a ton by going down this native plant restoration pathway, and we'll know more in 5 or 10 years. So now the other thing is spatial here. So spatially, it's not just a plant here, a plant there. You want a diversity of spatial arrangements. So patches and strips and larger blocks that have interiority are all important. So strips being connectivity that connects places and allows for migration. Patches being, at least you got somewhere to land and feed and reproduce. And larger blocks, there'll be unique species in the larger blocks that aren't in the patches or the strips. But you might need the strips to allow for reproductive movement between larger blocks. So this is landscape ecology. And this is landscape ecology that's very specific to a particular place, which is why studying your place is going to become important in taking on a habitat restoration project. You know, it's great to have the species. It's great to have the nectaries, all season, all color, diverse native plant species. Where it gets really interesting is figuring out where in the landscape is it going to do the most, and where in the landscape can we actually give land back to these wild processes in a really meaningful way. It's, not all places in a particular landscape are the same in terms of that question. So that's spatial analysis that you have to do, and it's fun and interesting, and sometimes very puzzling.
So we have changed everything.
Yeah, just about.
And have no idea.
Mostly, yes. And then the other thing is, if you can get away without using any agricultural and horticultural poisons, that would be really good, because those are the things that are really, really messing with these insects, both in the reproduction and in their ability to forage and find food and have nests. So this is sort of the starting point for how you think about a restoration project. Is the goals it's trying to accomplish. So let's look at a few of the specific land use practices that might come into play here, and then we're going to get you back with your buddies to actually imagine what would it look like to take something on in this regard, in maybe your sphere of influence even more than your whole under management. Okay, so a couple of land use practices: fallow and cover strips. This is really simple. This is one of the things that's really simple, and even the really simple things make a big difference. You know, I was talking to a farmer the other day who was saying, you know, the only way we're profitable is farming Fencerow to Fencerow, and that's true for a lot of people. But there's impacts of farming Fencerow to Fencerow even on your farm profitability eventually because of the loss of soil fertility and productivity. So the use of fallow areas and cover strips is, you know, it's this tiny, tiny step towards conservation agriculture that is one of the things that's most significant for is insect habitat. So on a bigger scale, these systems of banks and buffers and hedgerows and corridors are just teeming with life. And the more biodiverse they are, the better. Of course, the more biodiverse they are, the less functional they often are for agriculture. So one of the practices that's been emerging that's really interesting is, in the Midwest, they call it prairie strips. Around here, they might call it pollinator strips. But it's actually leaving, in other words, you don't have to design all of the diversity. You allow, and people do it through seed mixes, but you allow wild biodiversity to come back every X number of feet on your farm. So there's been, a lot of people here are working to be organic. There's research about how the presence of the prairie strips or the pollinator strips themselves reduces pest pressure, because those grassland and wild plant communities contain habitat for the predator and parasitoid insects who are reducing the pest populations on their own. So they bring in biocontrols that you would never be able to design yourself just through having enough plant diversity. And on a bigger scale, you can think about whole riparian buffers that include woody plant diversity as well as herbaceous, and then bigger scale corridor reconnection on the landscape. So this is really exciting stuff. And you know, there's a very long history of agriculture that is organized and oriented around these hedgerows and these corridors. And it really, I mean, in Europe, it was really not until the mechanization of farming around the Second World War when these really old, legacy, biologically significant hedgerows mostly got all cut down. But those people were getting firewood fuel from them. People were getting all kinds of economic resources from these hedgerows, as well as what they do for the wildlife. So those are things to think about.
So those do not look messy.
No, in some cases, no. I mean, down here, this is a agroforestry corridor, but if you zoomed in, it would get a lot messier.
Oh, good.
You know, that's very oriented around echinacea and Queen Anne's lace, obviously, or not Queen Anne's lace, black-eyed Susan. But and this you can bet that's pretty messy in there. Okay, so cover cropping and improved grazing is actually an insect habitat strategy. And especially it is the diversity of the cover crop that makes the difference. Because the more diverse cover crop you're using, the closer you're getting to whole season nectary during the time that the cover's on the ground. And same with diverse pastures. So some of the insect research has found that diverse pastures and diverse cover crop is considered actually classified as high quality insect foraging habitat. Not even just acceptable or medium, but high quality insect foraging habitat, whereas single species pastures or single species cover crop are considered quite low quality. So now that's good because there's benefits to both cover cropping and grass management of having a lot of plant diversity in your pasture. And when you're assessing your pasture quality, one of the things you look at is species richness. So, and species richness of grass, species richness of legumes, non-legume forms. Those are all things that are associated with insect diversity also. Yeah?
Do you have specific recommendations for native cover cropping techniques?
Yeah, it's a good question. There's very few native plants that are used as cover crops. Partly because there's not a lot of high biomass annual native plants to draw from this region. So a lot of the cover crops are high biomass producing annuals that are from Eurasia. So I've never seen anyone really dig into that. But what some cover crop mixes actually do have is a little bit of a wildflower component to them. And but it's usually not more than 5 or 10%.
Right, and some of those wildflowers are not necessarily used.
Sure, yeah. Yeah, I don't know. That'd be interesting to look into. I think there's probably, you'd have to really design it and do a lot of trials because the effectiveness of the cover crop for the soil building and the ability of it to integrate into the schedule of your other cropping might be very different depending on what the plant species are. So, good big thought though. I appreciate that. Yeah. Okay. Okay, tree-based agriculture. Tree-based agriculture. Just one other image related to this. Obviously the big challenge with fruit agriculture is pest management. And so one of the things people do sometimes with their small fruit, because they're taking a lot of economic losses to birds, is they will have kestrel boxes in their small fruit production areas as an alternative to netting, and that's very interesting. Then there's also the fact that you want the birds to be eating the insect pests, so you have to figure that out. But another just image of kind of how people are integrating the wild with their farming. There's this amazing big scale. They're not organic, but they have blocks that they're bringing into organic fruit farm in the Lower Hudson Valley called Fishkill Farm that some of you probably have been to. Busloads of people come up from New York City, and so they have 300 acres deer fenced. 300 acres of fruit trees deer fenced. So I just want you to picture that, right? that is someone. My friend runs the cidery there, and she told me that was a $125,000 deer fence that went up, which is a lot of money. And what they did in a very smart little move is they put coyote tunnels under the deer fence because they wanted the coyotes to be able to pass through the fence and hunt the rabbits and woodchucks in the orchard. So they used wildlife tracking to figure out where the coyotes were trying to get into the fence, and they just put a tunnel there that was too small for deer to move through. And so they created a coyote permeable membrane, basically, which is really amazing. Oh my goodness, we're off track here. Come on. Oops. What the heck just happened? Yeah, what the heck just happened?
Technology was saving you.
Yeah, always.
Maybe it's right.
It could be the projector that fell asleep, I think.
Yeah. Oh, yeah, okay.
I don't know if that's what happened.
Yeah, I don't know. We can proceed. That's not. I don't think we can proceed without slides if we need to. Thank you for your help.
Do you want me to try calling someone from test?
Sure. We only have a few more slides left, but it'd be nice to have them. There's one picture in particular I'd really like to show, if you're able to.
Yeah, sure.
Thank you. So, just to say that tree-based agriculture is it's a meaningfully different level of biodiversity and a meaningfully different level of nectar production than without trees. And, we spent a lot of time in the last workshop talking about the challenges and restraints on incorporating trees into farms, and those are very real. But there's lots of other landscapes that trees can be incorporated into too, and there's advantages of adding trees to farms if you can figure out how to do it. So, a lot to think about there. I'm going to skip this next one. Yeah, boy. Hope this works. So, okay, I'm going to talk about something without an image of it, and I'm going to try to describe it in a way that you can see, and hopefully we'll get the image back. So, who's heard of something called rain gardens?
Of course.
All right. So everyone's heard of rain gardens. Almost everyone's heard of rain gardens. So rain gardens are one of these really, really fascinating design interventions that solve multiple problems at the same time. So, in reference to the Worcester wastewater treatment plant, the very big scale pollution issue into the river is kind of a grotesque example of a problem that's distributed all over the country and world of what is called combined sewer overflows. So basically, when these systems were laid out underground 100 years ago or so, usually they were set up, and almost always they were set up where the sewer system is the overflow for the stormwater drain system. The sewer system is the overflow for the stormwater drain system.
Actually, the other way around.
Well, no, I'll get to that.
Okay.
So what that means is that when the storm, it's intentionally set up that way so that the streets aren't flooded by the stormwater drain system backing up.
Right.
So when the stormwater drain system backs up, it backs up into the sewer system. But then that means that the sewer system also backs up into the stormwater drain. And then you get raw sewage going into water bodies because all the stormwater drains empty into the local water body. So Cambridge, Massachusetts actually went through the process, and that's obviously a very wealthy city, but they went through the process. It took many years and a lot of money, but they went through the process of disconnecting their CSO. They went through the process of disconnecting their stormwater system from their sewer system. And it took over a decade, cost hundreds of millions of dollars. They did it. So it is possible to be done. But if you don't live in Cambridge, no, thank you so much. If you don't live in Cambridge and your community can't pull that off, what rain gardens are designed to do is increase the infiltration rate of otherwise impermeable ground. So the rain garden is designed to act like a very miniature constructed wetland. So it's a basin that's filled with very high organic matter soil. And so it's designed as a sponge to swell up with water during a rain surge and then re-percolate that into the soil, not into the stormwater system, in a short amount of time. So, okay, that's really good because that takes water pressure off of the stormwater system, which reduces the amount of sewer overflow that happens in the water body. It's really measurable. Hey, there we go. We have our rain gardens. There's a street lined with rain gardens. Now, you can design them with something called curb cuts. So a curb cut is this little detail that you can see right here in this picture. So the curb cut is designed so that when water's running downhill on the edge of the street, because usually there's a little waterway on the edge of the street, these little engineering distinctions, right? A little waterway. The curb cut is a break in essentially the swale wall of that edge of the street. And so it directs that water flow right into the rain garden. So it basically pulls water off the street into the rain garden. And then downhill there'll be another little curb cut to let the water back out when the rain garden overflows. So when you're designing a basin, you always need an overflow. And so the curb cuts are both the what directs water into the rain garden and also overflows it. So that's just details of how to maximize the effectiveness and the amount of water they pull out of the stormwater system. So you might be thinking, what does any of this have to do with insects? Well, what makes these rain gardens really effective at pulling nutrient and sediment pollution out of the water is being full of plants. And the plants that can grow in these rain gardens, they're the perfect setting for all of these native pollinator-associated woody plants, woody and summer herbaceous plants especially, that grow on the edge of wetlands because they're used to water levels rising and falling repeatedly, which is what happens in a rain garden. And they're some of the ones that are the hardest ones to find places for in the landscape because it's very rare that you have those water conditions. But you have them in your little constructed wetland rain garden. So they're a big re-addition and restoration of nectar and very particular and diverse nectar resources in the places that might not have had them for a long time. So very heavy on rain gardens and this as something that can be organized and worked on a neighborhood scale and even a town and citywide scale, like the city of Seattle has been trying to do, some parts of New York City. So those are some ideas. Yes?
I'm just unfamiliar, so the first time I'm actually hearing about this. Would this be happening on public when the towns might not be keen on keeping up maintenance or cost of these? Or are these on private lands? Neighborhoods are just like
some of both. Some of both. They're the ones in Seattle are all public, and it's just part of the city's maintenance budget is taken care of. They're not that high maintenance, but you do have to manage the vegetation community to some extent, and also if one of them blows out from a really big storm, you got to take care of that. So these are just some, and then there's actually like the long, slow restoration of a whole ecosystem, which is really the project of longer than a couple of years. It's a generational project. But those are just some ideas and images of what some of these interventions and technologies can actually look like in terms of how to specifically get more habitat and nectar resources back into the landscape. So now I want to invite you to spend the last 10 minutes here designing an intervention or starting to design an intervention. So I'd like you to get in groups of 3 this time and see if you can identify one land use intervention that you can undertake this year that is either within your current whole under management or it's beyond it and you can think of specific people you can invite to collaborate with you. And then see if you can think about which level of work you'd have to engage next. What level of work is sort of required for the current situation of this land use change? And how you would be shifting towards these principles and practices for insect habitat that we talked about. So I'm going to take about, and then there's one more. Oh yeah, and then what else do you have to learn? What else do you have to learn to be able to get started? So we're going to take 8 minutes to work on this in pairs or trios, whatever you can find. But have a quality think about if you were going to take something on this year, This is a structure to use some design thinking to figure out how you might organize and structure that. So have at it, and we'll hear from a few folks right at the end. Thank you for coming. Yeah, a little bit. Yeah.
Well, I don't know. There are so many.
Okay. Yeah. We'll go some machine.
Go for it.
Well, if you have to get
It's a change.
yeah. But it also
So you would have to be a little
it's a little
Take about 2 more minutes, about 2 more minutes.
What about if you get a college kid and you go to high school and get these images?
All right, come on back, everyone. Come on back. We're almost done. You made it. Okay, so I'm especially interested to hear what was the value for you in using at least some kind of structured thought process about this question. So, well, and see if you can be specific. What did the structured, because this, this is just one process, it could be many others, but what did the structured thought process do for you? If you were to observe yourself and how you engage with it. Yeah, right here.
Well, I made a whole list of the sort of places that we have, because we're very rural.
Yeah.
And I've got intentional wild areas, and some of them have been maintaining themselves and diversifying for 20 years.
Right.
But adding native plant species and making a better point of a full spectrum of colors is, I know that, but now I just thought about it on purpose.
Right, there you go. Yeah, thinking about things on purpose has value sometimes. Yeah. Did you have something over there?
Yeah, just considering the levels of work, and when I thought about everything I wanted to do, at least what I think is on a stabilized.
Yeah.
And I think it's probably where my guess is that a lot of people are probably at that point.
Yeah.
Try that, might that operate? No.
Yeah. So that's a really good way to check something is to ask, is this? And really be discerning about what you see. Because, there's what we want things to be, and then there's actually perceiving what they are. Yeah.
Having the limitations of a structure can help me be more creative. Mm-hmm. By not being able to just be free-flowing, then I need to really think in different ways from different angles.
Right. Yeah, so you'll take this and do what you'll do with it, but I hope this gave you a taste and experience, which you probably already have from other parts of life, of if you do really want to take something on, structuring how you're going to do it and how you're going to design it and what you need to learn and figure out in order to do it successfully. There's a lot of value in just ordering and organizing all of that. And I think a lot of why we sometimes struggle to really take things on and do things is because we haven't really structured what it would take. And so I think there's value in that. And okay, so and then one thing I
have a slight demurral here.
Sure.
There's a certain extent that cognitive styles are involved. Like for me, I wasn't on that list in what I was thinking because how do I stabilize area of concrete? There's no.
Totally.
It's below the stabilized.
Right. It's like it needs to actually be destabilized first in order to something else to happen. Yeah.
Well, you're not stabilizing the concrete. You're stabilizing.
Right.
You're reviving what's underneath the concrete.
Right, but the habitat was stabilized.
It doesn't exist.
Right. Concrete.
Yeah.
Not in a good way, though.
I would love to hear one or two things that people realize they need to learn next.
Everything.
Well, let's be specific though. Yeah.
We decided that there's a learning process about what is considered an invasive plant.
Yeah.
There are lots of things online that can help identify them.
Yep, and discernment is valuable there too because there's a lot of kind of categorical black and white thinking in how we think about introduced species, and so the more discerning corners of the invasion biology world talk about invasiveness as a quality that every non-native species does not have. Right? So there's greater and lesser degrees of invasiveness in a given place. Right. Now the particular value of the native species for this conversation is the specific symbioses they have with insects. right? So there's particular value to that for insect restoration. There are other design goals for which non-native species might actually be more valuable than native species for certain outcomes, right? And so again, it's about discernment and thinking about the overall system shift that you might be designing.
Besides, but native means is changing pretty rapidly.
It's like,
20 kilometers a year. Yeah. How do people define native in the first place?
Right. And
what settlers?
Yep. And often it's really oriented towards like the 1950s, if you really think about it.
The good old days.
Organizations that are addressing that.
Yeah, and
they specify like invasive plant atlas of New England.
Yep.
is an organization.
And there's some interesting and challenging implications that we have to grapple with around like the management regimes that are being implied by some of the invasive species strategies are basically they're basically glyphosate forever. That is the management regime that is being implied by the goal of completely removing a plant species from the landscape. So I think there's just a lot of nuanced, context-specific thinking to do about that. And there's also cost-benefit analysis to do about what's actually worth going to. If you have a little bit of barberry coming into your woods, it's not that hard to take it out, right? If you have acres of barberry in your woods, mechanical controls are not going to work. You need animals or fire or something else. Repeated mowing for many years, or deciding that it's okay. But those are the kind of questions. Yeah, and I know we have to go ahead and head out, and this is not mostly a workshop about invasive species, but yes.
Just resources for plants and pollinators.
Yeah, resources for plants and pollinators. Well, it's so specific to where you are, and I think that one of the projects to take on is to find the people in your local, like in your county, let's say, or in your local geography, who are doing native plant propagation. Because just because they have a nursery doesn't mean they're actually doing propagation. They might just be buying things in. But this kind of work is going to require significant germplasm propagation. So finding out who's already doing that is a good start, and then seeing if they can source you with what you're looking for. And learning how to do some propagation yourself is an interesting thing. And we're going to make all kinds of mistakes in the coming decades. It's going to be really messy. So we might as well make some interesting mistakes and not be too precious about it. Would be my recommendation. Because we're way past the point of being able to do anything perfectly. Yeah. So with that, my friends, I've kept you way too long. It's 5:32. What am I doing? Share. Travel safe. Thank you for coming.
Thank you.